So let's get into the agenda of today's webinar. First, we will discuss about ENVI and its significance in image processing, different types of ENVI modules that we have, and ENVI and its remote sensing data support, and then managing raster using ENVI, and then understanding about the pre-processing tools that we have in ENVI. And then we will talk about the most frequently used approaches like change detection, classification, feature extraction. These are like most popular applications, right? So we will discuss about these applications, how to perform this in ENVI. And also we will talk about a specialized module in ENVI, which is called ENVI Crop Science for Precision Agriculture. Another topic which includes is ENVI Deep Learning. So how ENVI is incorporating the AI/ML version of the technology with its rasters and image processing within its single interface, right? So then we will obviously conclude our webinar series with the key takeaways, and we will discuss about our next session. I will introduce about the next sessions, and that this will be our whole agenda for this webinar, right? So, okay, so let's have one poll here first.
So we request you all to just mark your answers here. You can see the poll questions on the right side of your screen. So we have about 30 seconds more. Okay, so I think the poll has ended and we have got some answers here. So majority of them are RGS Pro users, is what we have realized here, and then we have a couple of ENVI users and other software users as well. What do you do?
Okay, great. So that will give me like, how to pace myself. So since most of you are new to ENVI, so let's discuss about the software first. So it has been in the market since last 3 decades, and it is one of a kind of industry standard image processing software, which provides, data support not just from the optical, multispectral, RGB, but also it has the ability to handle the pre-processing part of the narrowband imageries like hyperspectral, and also with the help of the special modules within it, it is also able to perform like analysis on SAR data sets, extensive analysis, I would say rather, right? So, and definitely the single band and panchromatic and thermal band, these all are supported within ENVI. So, what is special about ENVI is that ENVI also has its own spectral libraries, built-in spectral libraries, which can be used for exploiting the information for hyperspectral data. And also we can build our own spectral library within it. And ENVI is also special for its guided workflows, which makes even beginner like very easy for the beginners, and it will help in you won't require, like I have described that there is ENVI deep learning. So it won't require you to know have prior experience regarding programming. So which makes ENVI is easily accessible to perform all sorts of analysis, be it from beginner level to the advanced level. Now let's talk about the ENVI modules. So why ENVI modules is important, because with the ENVI basic capabilities, there are some special capabilities which are like feature extraction, deep learning, crop science, which we perform like highly specialized task in that, right? So for performing such type of specialized task, for advanced image analysis, there is separate modules within ENVI. So these are like feature extraction module, DEM extraction module, atmospheric correction module, photogrammetric module, ENVI deep learning module, and ENVI crop science module. So feature extraction module helps in identifying and extracting the specific feature of our interest. Like feature extraction mostly works well with the higher resolution images, like 5 meter and less than 5 meter data. And DEM extraction modules is important to create accurate DEM for the geospatial imagery using stereo pairs. And atmospheric correction module is very important for our hyperspectral data sets, where we have two types of atmospheric correction, flash and quack. So in photogrammetric module, there is capability for geometric corrections and to generate point cloud data. And with deep learning, as I have already mentioned, we do not require any programming knowledge, prior programming knowledge, and we can build our pixel segmentation model or object detection model. So in ENVI crop science is special for monitoring the crop health and the yield predictions, and it also helps in finding out the hotspots in the count of crops. So this was all about the ENVI module. So, so moving ahead, I want to discuss about the ENVI remote sensing data supports within ENVI. So ENVI supports multispectral, hyperspectral, thermal, SAR, monochromatic, panchromatic, single band data, right? And also from different platforms based from aerial, drone, and satellite imageries. So it is kind of one-stop solution, the one-stop shop for all the types of data types you use, and also it has many support for the scientific formats like NetCDF, HDF, and HE5, hierarchical data formats. Type of scientific formats also it has been supported in ENVI. Okay, so we are moving ahead to the next poll questions about what type of data that you are using. So kindly we have the poll questions.
Yeah. So the next question is, what type of data do you primarily work with? Right. So we see a lot of people working with multispectral, hyperspectral, just visual RGB for photogrammetry, LiDAR, SAR, and if there is any other data that is not listed here. So we would like to know about that from the audience. Right. I think the poll has ended here. So yeah, I think multispectral has the highest users. Most of you are using multispectral, and then we have visual RGB users mostly. Okay,
Okay.
let's go ahead.
Yeah, thank you. Okay, so you are using multispectral and visual RGB. So it's great that today we have a webinar that about hyperspectral too, and also some panchromatic bands related some demos too. Okay, so moving ahead. Our next topic is like managing raster using ENVI, right? So managing raster, first of all, when we open our data in ENVI, we want to know how to handle the rasters. So either we want to build stacks of bands, either we want to build stacks of layers, or we want to convert the raster data type, which may be in 8-bit unsigned to 16-bit unsigned, right? So these is where raster management toolbox comes into picture, where it provides management tools for the rasters for efficient image processing workflows, right? So like we also have tools for converting the interleaves, like BIL, BSQs, and you can convert this BIL to BSQs, right? And then there are toolbox where you can create the ENVI meta files or edit the ENVI headers. This is metadata file of the images, and we can resize raster both spatially and spectrally. Spatially means by the location, and spectrally means by band. So I will show you all these tools in a while after explaining the pre-processing part, right? So the pre-processing workflow is like one of the workflow that ENVI has provided because it is most frequently used workflow. So these type of tasks are bundled as a workflow in ENVI. So which has this procedure where you have to select your data, then calibrate, and then provide do atmospheric corrections and do ortho rectification if required, and then you export your data. So we have this type of guided workflow as you can see on the screen, right? So the other side, you see the snapshot of our toolbox called Flash, which is one of the atmospheric correction toolbox. I will show you that in the interface itself in a while. Right? So another thing, I have provided here an example pre-processing steps for hyperspectral. So how does the pre-processing in hyperspectral looks like? So first, what we do is we check the bad bands, and then we jot it down, and then we resize our raster both spectrally and spatially, and then we check the projection. In this case, this was the Prisma data I had. So it had VNIR, SWIR, and PAN bands. So I did the projection checking of those, and if required, I did the projections. And then I have stacked the VNIR and SWIR for the purpose I was using doing this pre-processing, and then also applied pen sharpening on the image. So after doing all this, I have applied atmospheric correction using Flash. So a quick demo. Okay, so this is our ENVI interface. Here we have option to open as different types of sensors are provided, like optical. In optical, we have Sentinel-2, Sentinel-3, and also we have different like Maxa data can also be imported, and also the Prisma data, which I was talking about, the hyperspectral data. And also there is support for the radar sensors, thermal sensors, and the digital elevations. And there are some scientific formats and net CDF and HD4 formats, and other military formats are also available. So in this way, we open our data, and here we have some analysis tools, like this is our spectral profile. This is to get the arbitrary profiles, and these are this image stretching methods, right? And these are the histograms, and this is for making ROIs and all these. So right now, as I was talking about the raster management, so we have the whole toolbox here called raster management toolbox, where there is different options for resizing rasters, stretching our data, reproject our rasters, replace bad lines, right? And the workflows which I was talking about, so ENVI has bundled all the workflows here, and where they have provided important processes like anomaly detection, automatic image registration, change detection, pre-processing workflow, spectral hourglass workflow, which is important for hyperspectral data sets, and target detection workflow and vegetation analysis workflow. So they have provided this workflow, and beyond this, there is one more workflow which is related to the classification and also thematic change detections. So here, after opening my Prisma data, this is how I can see. Just a while. So I can see that this in the data manager, it has VNIR, SWIR, and bands, right? So so to check our data for the bad bands, what we do is that we do the band animations like this. We can check our bands. We can control the speed here and check the bad bands. So by bad bands, what I mean is that in the initial part, as you can see, there is some noises, right? So you can remove, if you don't want that band, you can remove that that band, considering it as a bad band, right? So, but these are all are without noise, so you can consider it for the further image processing. Another thing that I want to show you is that how you can resize your data. So this is how you get the option for spatial and spectral subset, where you can subset it using ROI or by the view. So right now, say for my view, it is in the just. So if I want to subset by view, then it will show me the ROI on that regions, whichever is visible right now. And I can subset it further. And also we can subset this bands. Here apply BBL means I have already created the bad band list here by finding out that these are the bad bands. And when I apply BBL, it will select only the correct bands, right? Then it will remove all the bad bands. So this is how we do the bad bands removal. And for geometric correction, we have the whole toolbox for georeferencing from different processes. So here I have used georeference from GLT. GLT is a geographic lookup table. So I have georeferenced this data like this, right? So, and also we have option for the pan sharpening, or you can say the image sharpening using different algorithms. So you can use gram schemate, sorry, and CN spectral sharpening, etc. So here what happens is that you input your lower resolution raster and higher resolution raster. So in this case, pan will have higher resolution, so you will input the high resolution pan here and the low resolution raster in the first as an input, and then you provide sensor information which is optional, and then you generate your output. So after generating, doing the pan sharpening, the pan sharpened image will look like this, which will be more clearer than the previous. So as you can see, the resolution of the previous, which is not sharpened, is quite blurry. And when I have sharpened, my features are a bit, in a higher resolutions. So in this way, we do different types of pre-processing method. And now moving ahead, I will switch to my presentation. So we have, I think, third poll here coming up.
The third question that we have for you is, what is the most challenging aspect of image processing that you faced? Right. So, what is the one that keeps you scratching your head in time? Is it the data compatibility with the software? Is it the ease of tool sets or the processing tabs that you have? Right. So that becomes complicated sometimes. Or is it the data storage and sharing? Right? So imagery data sets are usually high in volumes, large volumes. So do you have problems in data storage and sharing? Do you have problems in analyzing that imagery, or is it something else? So we would like to know about it. Yeah, I think we have got the answers to it.
Yeah.
What do you do?
Yeah. Okay, I think analyzing imagery is the challenge, right? So yeah, I can understand that part. First, to understand image, we have to really be thorough about the imagery concepts first. Then we can understand the behavior of different bands by applying different algorithms when we're using it for different applications, right? So that is how we begin for imagery analysis understanding. So change detection is my the next topic is the change detection. So here in ENVI, we have different types of change detection method available. One, we can do the temporal change also, another thematic change, and another one is the pre and post change detection, for which we have the workflow, right? And for thematic change also we have the workflow. By thematic, it means that you have already a classified image in your hand, like two classified image of time A and time B, right? So now you want to see which classes has changed to which class over the time in that particular region. So in here, as you can see the snapshot, that some classes one has been changed into the classes two, right? Some different cultivated areas change into the estuary, water bodies, like that. So so it will also help us to generate class-wise this metrics that and the area of change, and this is the basic workflow is mentioned here. And another type of change detection that we have is pre and post. Like as you can see in this image, the pre and post you can see, right? So how we can find out the change in that. So you have, for that we have a direct workflow where you select the data, do image registration if required, and calculate the change using different algorithms, and then you fix the threshold there to get the optimum output, and then you vectorize and then export the result. So I will show you the quick demo on this. So this is my change raster, the time A and time B raster of Jewar Airport, which is in Delhi NCR region. And I have used, this is a change detection workflow where you have have to input your raster 1 and raster 2 and proceed further like this. So for this case, I can skip the image registration, and you have here different algorithms for calculating the change, right? So we select those algorithms and select our bands and then set the threshold. For now, I'm just using, say, enough, and set the threshold. So here the red and the blue regions are showing, the blue regions are the increase and change. Both are changed. One is increase and another is decrease. So we can set a threshold like this, and then we can. For now, I'm just for demonstration purpose, I'm just sticking to this, and we can also vectorize change. Um, Before doing that, we can smoothen our pixels and kernel sizes and export our results in different formats, be it in classified raster form or in the shapefile, in the JSON format or KML, right? So yeah, in this way, you can export your results, and it can be also opened in the workflow modeler, like ENVI modeler. So for now, I'm exiting this workflow. I have, in the interest of time, I have already created one output, generated one output for this. So I am having, say, this result where I'm having the class of increase and decrease, right? So over the time, as we can see in this region, there was no airport construction in 2017. Now in 2024, we are having some significant change, which since I have used just band 2 here, which is the representation of the built up and the changes in the vegetation and built up areas. So it has shown me that these areas have grown in the built up regions, and another has some decrease in the vegetations. So this kind of analysis it has provided. So in this simple few steps, you can generate your classification results. And now let's talk about the classifications. So classification, as we all know, that we have, it is used for categorizing the pixels in an image to different classes. It can be done using supervised and unsupervised method. For supervised, I have listed down the different types of algorithms that we have in ENVI. And for unsupervised, we have isodata and k-means. And we also supports like post classification if we want to do some corrections in the classes, if we want to make aggregate of some classes, combine classes, clump classes, or sieve our results, like to remove the noises in the classes. That can be done. Okay, so a quick demo on the same. So here. Let me. So this is how we zoom our layer to extend. And then we have this whole toolbox for the classification, where we have classification workflow, which is also like guided workflow as I have shown you right now. And these are the different supervised and unsupervised method, and these are the post classification methods. And we can also, build a decision tree to say that this band should be of this range, and then we can make a decision tree to get our desired classes, right? So here I have just tested a few of uh, class classification method, like I think, yeah. So this one is maximum likelihood, and another one is the unsupervised. Unsupervised is means when you are allowing the computer or your machine to detect the unique pixel values without giving any training samples. So this is how it has detected, and then we will give a class name to that groups, and then we will classify after getting those unique classes, right? But in supervised classification, what we do is that we provide training samples first, saying that these are the pixels which will belong to this particular class. Then the machine will use the algorithm for detecting those type of pixels. So this is how unsupervised and supervised classification differ in each other. And now moving ahead, okay, so one more thing that I want to show you here is that I was talking about the feature extraction, right? So feature extraction, we have the whole toolbox in here where feature extraction can be done using example-based feature extraction workflow, which is more similar to the supervised classification, but it is not a classification. Here you are doing the image segmentation and extracting out the objects, right? So it is not pixel based. So here you are providing examples of your objects, like say car, that you want to that is your feature, and you are providing the examples for that features, and then you are extracting those features. And another is rule based feature extraction workflow, which what happens is that you control spatial, spectral, and textural property of the that image. So now say if you are having road like asphalt, you want to detect asphalt, then uh, if you want to detect the asphalt, then you have to give spatial characteristics as linear, and the bands which will highlight the spectral asphalt of the dark asphalt values, right? So in this way, and the texture of the asphalt will be smooth. So you will add some smooth features, texture, and range to it. So in this way, you will have more freedom to control which feature that you want to extract through these three types of properties that we have: spatial, spectral, and textural, right? So output of which I'm going to show you output of which I'm going to show you in the presentation now. So so these are the different types of feature extraction that I have done in different types of data sets, multispectral, and one was the this was the average data, and this was the multispectral, and this was again high resolution multispectral data, and this was the water body was done on the pan image. So even in single band image, you can perform this feature extraction method if you provide proper textural and spatial information to it, because we have only one band, so spectral information won't be that efficient. So you provide textural and spatial information to it. So in this way, I have extracted features like aircrafts, helicopters, asphalt, ships, tanks, and water bodies. So here I have created different rules for all of them, and such types of rules can be applied for extracting like aircrafts. The rules which I have made for the aircrafts can be used for extracting the aircrafts of the similar resolution image. So I think we are moving ahead to the fourth poll questions. Can we have the poll number 4?
the question is on your screens. So where do you apply image processing more often, right? So what kind of applications or what kind of data sets do you apply image processing on? Is it hyperspectral analytics that you do more often, or is it a change detection kind of application, or the use cases or tool sets that you use? Or do you use photogrammetry mostly? Right? So photogrammetry for drones, man aircrafts, right? All of that that is happening. Apart from that, do you use image processing for SAR? Are you SAR expert and you wish to do image processing on SAR imagery, or if it is image classification, you are looking for classification kind of applications, or is it something else? So we would like to know about it. I hope you have all answered your questions. Great. Yeah. Over to you, Lavin.
May I have the answers? Okay. 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 So next topic is about the ENVI crop science. So it is very specialized module we have for the precision agriculture. So here we can find out the total count of the crops with the location and the size, and calculate the different statistics like mean, median, and standard deviation for each crop's metrics. Like it can be for height of the crop and the spectral index value of the crop. And another can be we can identify the gaps. We can identify the hotspot, do the hotspot analysis using the vegetation health indices, and also change in those hotspot images for the 2 dates, right? And we can also extract the management zone boundaries. So here you can see the snapshot of the toolbox, which I will also show you in the demo in the ENVI interface. So this is where we have our crop science toolbox, where we have bundled a whole lot of tools related to agriculture. And in this demo, what I have done is that I have extracted first. This was my input image, and then I have calculated the GDVI, green difference vegetation index, and created a mask out of it, and then got converted that GDVI using the count crops, and then got the crops along with its shapes and locations. So as you can see, it has detected different pumpkins which are lying on the ground by using this GDVI indices. So this is one of the examples.
Sorry, we are not able to see you.
Not visible.
Okay.
Sharing it probably would.
Is it visible?
Still on the presentation.
I think you share your screen, not the presentation.
Yeah, just give us a minute. We are trying to fix it. Which one? Yeah.
Okay.
Sorry for the glitch.
Sorry for the glitch. So this is my input where I have extracted the GDVI, green difference in vegetation index, and then generated a count using this count crops tool. I have generated this output where I get the count of the crops along with its locations and its shape, right? Now moving ahead to the next topic, which is the last topic of this webinar, is called is ENVI deep learning. So in ENVI deep learning, what we have is that we have this we have this as a separate add-on module, and the workflow is built on TensorFlow and Keras. And here the procedure is just to label our data, then train our model, evaluate its performance, and then use it for the classification. So there can be different applications, be it pixel segmentation and object detections. And here are some examples of the deep learning target detections. Here are some snapshots related to the LiDAR derived input, which are converted to the raster for like extracting the road network. So I will quickly take you to through the demo. Please let me know if my demo is visible or not. Okay.
Yes, it's possible.
Okay. Thank you so much. So in this case, so this is our whole deep learning toolbox where we have different pixel segmentation and object detection workflows. We also have newly introduced this grade-wise pixel detection, pixel classification and object classification methodologies. And here also we have guided deep learning and deep learning labeling tool where we save our projects and then import our save for now. So in this way, we save our projects. Here you have seen this classes 111 because it is right signaling only, and label raster as okay because I have trained this model using this by selecting this, right? So if I select the object detection here, then we set some number of epochs and patches per batch, and give some background patch ratios and select our output model path, and then we save this model in .h5 format. So in this way, we do the labeling, and for the classification, then we load our model for, say, in this case, the object detection classification. I will load my raster for test, the test raster, and input my trained model and set this confidence threshold and IOU thresholds, and then generate my classification vector. So by using this type of workflow, I have generated one output here. So before that, I would like to show that this was my the input images for training was like this. I have used several other images too, like 6-7 images for this type of demo. And then I have tested on the completely new image, and then generated the output using the trained model. So in this way, there are some miss in here, but that can be rectified by improving our training data sets and controlling our confidence threshold. So in this way, deep learning for object detection I have shown, and similarly we can do it for the pixel segmentation too. So now, so this was my last demo, and now what are the key takeaways from the today's presentation, right? So ENVI's user-friendly interface and streamlined workflow, as you have seen, makes it easier for users to begin with. And then it supports a wide range of data formats and sensors, which provide versatility for applications in diverse sectors. Different ENVI modules helps in performing highly specialized tasks using ENVI. And ENVI is a one-stop solution for processing and managing imagery ranging from optical SAR to hyperspectral. And it has easy to use change detection and classification workflow along with the post-classification methodologies. And we have also seen how significant ENVI is for the precision agriculture and ease of performing object detection using ENVI deep learning. So these are the key takeaways from today's webinar. And our next session will be on redefining SAR imagery analysis using ENVI SARscape, which will be the fourth webinar on August 2nd from 11 to 12 at the same time. So kindly register for that too. And yeah, this is the wrap up for this webinar series. Over to you, Sanket.
Thank you. Thank you, Lavina, for all this insightful presentation and demonstration. So we have a lot of questions here in the chat box, right? So we have got many of them. I was expecting we wouldn't get this many, or else we would have started answering them in there. But yeah, we would be happy to take a few of them right now. So I have my colleague Manusha along with me, who would be helping me with these questions, right? So I'll read out the questions. So first of all, from Ashia to all panelists, good morning. Drone data is supported by which module? So drone data is supported by photogrammetry module within ENVI. Apart from that, we must have gone through yesterday's webinar on photogrammetry in ArcGIS, right? ArcGIS Reality and other modules. So yesterday's webinar was completely around this. Right, so if you haven't gone through it, you will get the recording shortly. You can have a look at that. In ENVI, it is supported on the photogrammetry add-on. Next question is from Mr. Robert Sayo. Can ENVI and ArcGIS Pro work seamlessly? Does ArcGIS Pro have plugins for ENVI tools to be used?
So yes, they both work seamlessly, as we rightly mentioned, and we can import the some of the ENVI tools directly into the ArcGIS Pro. If you have
Next question. While performing classification, can we preview the area statistics for each of the classes before converting it into vector format?
Yes, we can do that. There is an option of quick statistics also, and there are other ways also that can help us with the area statistics.
The next question is from Sarvana Kumar R. Hello, sir. Good morning. Please tell me how to use label from ground truth value for supervised learning. I have shapefile for the ground and satellite multispectral in TIFF format.
We can directly integrate it in the from wherever we are taking the ROIs. We have different options there wherein we can import the vector file, ASCII file, and there is one more option. So it is very much there within the tool itself.
Dr. Mohit Kumar wants to know, as ISRI provides 21-day free access to ArcGIS, is there any such provision for ENVI? So for ENVI, we do not have such provisions as such, sir. You can please write to us at info@sd.in, right? So we would like to speak to you. We would like to understand the kind of applications that you work on, and we would take a look about it and try to give you a trial licensing. Then we have a question from Manoranjan Ghosh. Will you be sharing this PPT? Yes, we will be sharing this webinar recording itself completely so that you can go through it later in case you have missed some part of it. Next question is from Murul. He is from Azerbaijan, Baku. Which crop classification algorithms can we use or AIML based?
As Lavina just mentioned, we can directly use this classification using some of the indices that are directly there, or else using the deep learning toolset also, we can do our crop classifications. There are both the methodologies. We should just both of them.
Dr. Chandrasekhar wants to know if we make our own workflow for some process or application, can it be shared in form of a script with others or clients or an executable tool without requiring ENVI installation at the client end?
So from ENVI itself, using the ENVI modeler capabilities and generating the Python script from my automated workflow, we can generate this script in Python or IDL, which can be taken to any other platform, and we can create the tool from within the and use it as a tool set.
So when it comes to sharing the results or sharing the summary of the processing that you have done, right? So we would be learning more about that in the upcoming webinars, right? So we would be showcasing that and how you can share the end results with your customers, with other government agencies or other decision makers, so that they can see the summary of the data or visualize that and make their decisions accordingly. So we'll be going into much more detail in the upcoming webinars around this. Another question from Dr. Robert Silo. ArcGIS Pro also has deep learning tools and other AI tools. How does these tools differ from deep learning tools in ENVI? So even I was wondering about this question, Manjusha and Lavinia. So please address this for us today.
So both have their own capabilities. With ArcGIS Pro, like we saw, we do have pre-trained models on which we can build on. So there the user doesn't have to go from the scratch for many of the, I would say, models that need to be built. But then again, you do need to retrain your model or do some tuning within ArcGIS Pro also to get into the accuracy levels to what we want. As far as ENVI deep learning is concerned, we would say that we can again do both our pixel and object detections. And then, I mean, I would not say there is a comparison, but yes, they both differ in their own ways and they have both their own advantages.
Next question is from Dr. Chandrasekhar again. Can you suggest any good and recent journal reference paper where performance and capabilities of ENVI and other similar image processing tools or software are compared? So we would request you to just write us an email on info@sd.in, right? So with your use case and with the exact requirements, we would try to go through it and address it for you. Can you please share some training material for learning? So a lot of training material is available online, right? So you can just visit ENVI Geospatial website or Esri India Esri websites, right? So you will get a lot of training materials of all our software solutions. They're readily available for you. You would get videos, you can get tutorials, right? Step-by-step tutorials as well.